Now let us have a look at some questions here, which are based on these important formulae that we have discussed. Now, what is the sum of first 50 natural numbers? So four choices are given to you. We want the sum of first 50 natural numbers. So sigma n here we know is n into n plus 1 by 2. This shall become 50 into 51 by 2. 2 and 50 they cancel by 25. So 25 into 1 is 25. 2 gets carried over. 25 into 5 is 125. Plus this 2 shall be 127. So 1275 should be the answer which is given to us in choice C, which becomes the answer here. Now the same thing can be seen here. Now what is the sum of first 20 even numbers? Now for that you know the formula n into n plus 1. That is the sum of first 20 even numbers. So the value of n here is 20. So 20 into 21, which is 420, given to us in choice C, which becomes the answer here. Now, what is the sum of first 20 odd numbers? For that, we know the formula has to be n square. The value of n here is 20. So 20 square is 400, which is given to us here in choice C. So see, it becomes so fast and so simple if you remember the formulas. And that is the only way of solving these questions. Now, what will be the sum of squares of first 10 natural numbers? The formula you know is n into n plus 1 into 2n plus 1 by 6. So once we know this formula, you just have to substitute the value of n here as 10. So this is 10. Now 10 plus 1 is 11. And then 2 into 10 plus 1, that is 2 into 10 is 20 plus 1. That shall be 21 divided by the 6. So you cancel the numerators and denominators. So 3 sevens are and 3 twos are. This goes. So it basically becomes 770 by 2, which we know is nothing but 385. And 385 is given in choice B, which becomes the answer here. Now, what will be the sum of cubes of first 10 natural numbers? That we know the formula as n into n plus 1 by 2 whole square. So using that formula, we know that the value of n here is 10. Substitute 10 into 10 plus 1 by 2 whole square. So 10 into 11 by 2 whole square goes by 5. So 55 whole square, which is equal to 3025. Now, while writing all the numbers from 1 to 100, how many times will number 2 appear? Now, the number 2 will appear in the units place and it appears in the tens place also. So, in the units place, it appears 10 times, 2, 12, 22, 32, 42, 52, 62, 72, 82, 92, these 10 times. And in tens place, it appears 10 times, that is from 20 to 29. And these 10 are nothing but 2, 12, 22, 32, 42 and so on till 92. So in total, 10 plus 10, 20 times the number 2 will appear. So hence, choice B is the correct answer. When a number is divided by 175, then the remainder obtained is 132. So let the number here be x. When you divide it by 175, the remainder obtained here is 132. Now, if the same number is divided by 25, then what will be the remainder obtained? Now, it's quite simple. If this is the first divisor and this is the second divisor, the first divisor should be divisible by the second divisor. Then only we can solve such kind of questions and we can find out the remainder when the number which is unknown is divided by the second divisor, which is 25 here. So now we know that 175 is divisible by 25. So as 175 is divisible by 25, we shall divide 175 by 25. So on dividing 175 by 25, we get 7. 25 sevens are 175, and that will be the remainder when you divide this number x by 25. So choice B here is the correct answer. I'll give you another instance for this, another example. Now, from 175 and 132, let's obtain a number that is 307. Now, if you divide this 307 by 175, you get 132 here as a remainder. Now, if this 307 is divided by 25, goes by 25, 5 remains, 7 comes down, 50, 7 is a remainder. So the process is that the first divisor should be divided by the second divisor. Then the quotient obtained is the answer. But the point here is D1 or first divisor should be divisible by the second divisor. Very important thing. Now, if 1 square plus 2 square plus 3 square up to 10 square is given to us as 385, then 2 square plus 4 square plus 6 square up to 20 square will be how much? Actually, you don't need this. You can directly employ the formula for finding out the sum of the squares of initial n even numbers. And the formula, if you remember, is 2n into n plus 1 into 2n plus 1 divided by 3. So from 2 to 20, there are 10 even numbers. So the value of n here is 10. So it becomes 2 into 10 by 10 plus 1 into 10 into 2 plus 1 by 3. So this is 20 into 11 into 10 into 2 is 20, then 21 by 3 cancels by 7. So 77 into 20, which we know is 1540. So directly you can jump on to choice B. There is another way in which you can solve this question. Actually, we know that 2 square plus 4 square plus 6 square plus 20 square up to 20 square, we are adding up all even numbers. You know that 2 square is common here. So you take it common. What is left? 1 square plus 2 square plus 3 square up to 10 square. So the value of 2 square is 4. Value of 1 square plus 2 square plus 3 square plus up to 10 square is already given to us as 385. So you will multiply with 385 here. So still you will get 1540. So either of these two methods you can employ. Now the product of two numbers is 36 and the sum of the two numbers is 30. So let the two numbers be x and y, let us say. So xy is given to us as 36 and x plus y is given to us as 13. What will be the positive difference between the two numbers? I think the best way here would be using the shortcut. What is the shortcut here? Rather than using equations here, just factorize 36 now. 1 into 36, 2 into 18, 3 into 12, 4 into 9. Now out of these, the sum of the digits should work out to be 13. This 1 plus 36 is 37. We don't want this. 2 plus 18 is 20. 3 plus 12 is 15. But 4 and 9, the sum is 13. Now you want the difference. So 9 minus 4 is 5, which is given in choice C. That becomes the answer. The sum of two numbers is 40 and their product is 375. So let the two numbers be x and y. So sum, that is x plus y, is 40 and product, that is xy, is 375. Now what will be the sum of the reciprocals of the two numbers? That is 1 by x plus 1 by y is what we need. Now if you solve this, you don't have to use equations here. Don't waste your time. So if you solve this, you know that this is xy by x plus y. Aren't these values given to you here? Right? So xy is 40, x plus y is 375. Both these numbers are divisible by 5. So 5 8s are 40 and 5 7s are 35, 25. So 8 by 75 shall be the value of the sum of the reciprocals of these two numbers. So simply using this expression, you don't have to use equations here, please. Now the sum of the squares of two positive integers is 100. Let us say x square plus y square is 100. And the difference between their squares is 28. x square minus y square is 28. Now find out the sum of these two positive integers. So you can solve it by doing equations. I'll tell you another method also. So adding these two up, you get 2x square is equal to 128. X square equals to 64. So the value of x here is 8. So that means that 64 plus y square is 100. If we substitute the value of x here, y square is 100 minus 64, which is 36. So the value of y here is 6. Value of x is 8. So sum x plus y is going to be 8 plus 6, that is 14. Now the point I want to make here is that you should remember these two squares, that is 36 plus 64 equals 100. That is 6 square plus 8 square equals 10 square. Now this is something that you must remember. Then in that case, you don't have to use these equations. Immediately it will strike to you that 100 is a sum of two squares, which are 36 and 64. And 36 square root is 6. 64, the square root is 8. 8 plus 6 is 14. That's your answer. But still, just in case you don't remember, then you can always make use of these two equations. If a number is divided by 36, the remainder obtained is 19. So the number x is divided by 36. The remainder obtained is 19. If the same number is divided by 12, what will be the remainder obtained? Well, we solved a similar kind of a question and we discussed the concept. Now we know that 36 is divisible by 12. This is all right. So now our answer here has to be 36 by 12, that is 3. As simple as that. Choice C is the correct answer. Now if 7, 3, 8a, 6a is divisible by 11, then the value of a is how much? Now this is a question which appeared in one of the CSAT examinations. Now when I take these numbers 7, 3, 8a, 6a and employ the divisibility rule for 11, what is the divisibility rule for 11? The difference between the sum of digits in the alternate places, that should be either 0 or a multiple of 11. So let us take the sum of the alternate digits which are in the odd position. So 7 plus 8 plus 6. So 7 plus 8 plus 6 is 21. 7 plus 8 is 15 plus 6 is 21. And 3 plus a plus a. Well, simply we will have it as 3 plus 2a. Now, if the difference between these two has to be 0, in that case, 3 plus 2a shall be equal to 21, which means 2a should be equal to 21 minus 3, that is 18. 2 goes here, so a here is 18 by 2, and that is 9. So 9 is given to us in choice C, which is our answer here. Now, which of the following numbers is not divisible by 18? So what will you do? You'll check for the number to be divisible by both 2 and 9. So add up these digits. Don't do that. First thing is, 18 here is an even number. And a number which is divisible by 18 has to be an even number. Now this is even, this is even, this is even, but look at this number. Simply, this is an odd number. So it is not divisible by 18. So kindly look at the choices before you actually start working out, because it might turn out to be a waste of time by the time you reach the last choice. If the number 159 is multiplied first with 367, all right, so 159 into 367, and then with 482, it doesn't matter if it is multiplied before or after 367 with 482, then which digit will appear in the units place of the product? Well, very simple. We will only choose the digits in the units place of these three numbers. So 9 into 7 into 2 is what we are looking at. So 9 into 7 is 63 into 2. So again, we need only the units digit. So we will ignore the 6. Ultimately, it works out to be 3 into 2. Your answer here is 6. 6 will appear in the units place. So C should be the answer here. Now, sum of three consecutive even integers is 54. find out the smallest integer. Now these even integers can be written as, first assume an integer to be x. Now after that, the consecutive even integer would be x plus 2. And before x, the consecutive integer will be x minus 2, consecutive even integer. Now if we take the sum of these three, it equals 3x, and that is given to us as 54 in this question. The value of x comes out to be 54 by 3, that is 18, and our requirement is the smallest integer. The smallest integer here is x minus 2, which shall be equal to 18 minus 2. Hence, the smallest integer here is 16, which is given to us in choice D. That becomes the answer. Now, the question is asking, now this question says, what is the sum of all the natural numbers from 75 to 97? Now you see that 1 plus 2 plus 3 plus and so on up to 74, then plus 75, then plus 76, and so on, plus 96 plus 97 will be the sum of all the natural numbers from 1 to 97. But our requirement here is sum of these numbers from 75 to 97. So what we will do is, we will find out the sum of all the numbers from 1 to 97, and from that we will subtract the sum of natural numbers from 1 to 74, and the remaining amount shall be the sum of the numbers from 75 to 97. So sum of numbers from 1 to 97, from that we shall subtract sum of all the numbers from 1 to 74, and the remaining amount shall be sum of numbers from 75 to 97. Now sum of numbers from 1 to 97, we will make use of the formula n into n plus 1 by 2. This will become 97 into 98 by 2 minus sum of numbers from 1 to 74. So this shall become 74 into 75 by 2. Now here we can cancel 98 by 2. So we can get, so we have 49 in the numerator, and similarly 2 and 74 gets cancelled, and we have 37 in the numerator. So let us do the calculation part. 97 into 49. 7 9s are 63. 9 9s are 81, becomes 87. 4 7s are 28. 4 9s are 36, plus 2, 38. We get 3, 5, 7, and 4 here. So we have 4, 7, 5, 3, from which we have to subtract. Now let us do this calculation here. 75 into 37. 7 5s are 35, so 3 here. 7 7s are 49, plus 3 is 52. Then 3 5s are 15. 1 here, 7 3s are 21, plus 1, 22. You have a 5, 7, 7, and this is 2. So from this we are subtracting 2 7 7 5. 13 minus 5 is 8. 14 minus 7 shall become 7. 16 minus 7 shall become 9, and we get a 1 here. So 1978, which is given to us in choice D, will be the sum of all the numbers from 75 to 97. Now find out the sum of all the 2-digit numbers. Now 2-digit numbers will be from 10 to 99. So once again, we will take the sum of all the numbers from 1 to 99, from which we will subtract the sum of all the numbers from 1 to 9. So what will remain will be the sum of all the numbers from 10 to 99. Now see here, 1 plus 2 plus 3 plus up to plus 9 plus 10 plus 11 up to 98 and 99. So first we shall find out the sum of all the numbers from 1 to 99, from which we will subtract the sum of numbers from 1 to 9, and the remaining amount shall be the sum of all the 2-digit numbers, that is from 10 to 99. Now again we will use the formula n into n plus 1 by 2, which is the sum of n natural numbers. So here we shall get 99 into 100 by 2 minus 9 into 10 by 2 Now that is 9900 minus 90 by 2. So that should give us 9810 by 2, which works out to be 2 into 4 is 8, 2 into 9 is 18, and 2 into 5 is 10, 4905. Now this is given to us in choice D, which becomes the answer. Now how many digits will be required to write down all the numbers from 1 to 50? Number of digits we want. So from 1 to 50 we have single digit numbers, we have double digit numbers. So one digit numbers, each number should consist of one digit into total numbers, which are 9 from 1 to 9. So there will be 9 digits required to write down the numbers from 1 to 9. Now when we talk about two-digit numbers, these shall consist of 2 digits in the number, and from 10 to 50 there are in total 50 minus 10 plus 1 numbers, that is 41 numbers, because both 10 and 50 are included in this. So hence 2 into 41, that should give us 82. So 9 plus 82 will become 91, which is given to us in option C. Now you have another type of question here, and that is how many natural numbers between 30 and 200 will be divisible by 7. So from 30 to 200, we have to find out the numbers which are divisible by 7. Here we will find the first number which is divisible by 7. So between 30 and 200, first number which is divisible by 7 is 35, and this is our first number. Now between 36 to 200, there are 200 minus 36 plus 1 numbers. That is 200 minus 36 is 164 plus 1, that is 165. Now in these 165 numbers, every seventh number is going to be divisible by 7. So when we divide this by 7, goes by 2, 14, 25, 3s are 21, remainder is still 3. So 23 more numbers. So 1 plus 23, total 24 such numbers are there. This is given to us in choice D, which is the answer. Now look at this question. How many numbers less than 1000 are divisible by both 10 and 13? Now a number which is divisible by both 10 and 13 must be divisible by its LCM. So LCM of 10 and 13 is nothing but 130. So how many numbers from 1 to 1000 are divisible by 130? So simply divide 1000 by 130, or you can divide 100 by 13, removing the zeros. And we know 13 into 7 is 91. So the remainder shall be 9. So there are 7 such numbers which will be divisible by both 10 and 13, given to us in choice D. That is the answer. Now between 1500 and 2000, find out that number which will be divisible by both 36 and 102. So let us take the LCM of 36 and 102. Now 36 is 2 square into 3 square, and 102 is divisible by 2 into 51. So 2 into 51 again is 3 into 17. So the LCM here will be the highest power of the prime factor. Highest power of 2, so 2 square. Highest power of 3, so 3 square. And highest power of 17 as it is. So this is 36 into 17. Now 17 into 6 is 102. So 2 comes here, 10 goes. 17 into 3 is 51 plus 10 is 61. Now between 1500 and 2000, we have to find out that number which will be divisible by both 36 and 102, which means the number which is divisible by 612. So simply 612 into 3, if you take 3 2s are 6, 3 1s are 3, 3 6s are 18. 1836 is that number which is divisible by both 36 and 102, and it's LCM 612. So choice C here will be the correct answer. Here, which least number should be subtracted from 36798 so that the result obtained will become completely divisible by 78. So simply you divide 36798 by 78, and the number which should be subtracted from 36798 should be the remainder that is obtained after dividing the number by 78. So it goes by 4. 8 fours are 32 and 7 fours are 28 plus 3, 31. Remainder is 7 minus 2 is 5, 6 minus 1 is 5. So it is 559. So goes by 7. 7 8s are 56, 7 7s are 49 plus 5, 54. 3 and 1, take down 8, 138. Now if we take 78 into 2, it will be 156. So let us have 78 into 1, that is 78. Remainder here is 60. So 60 is that number which, when reduced or subtracted from 36798, will give us a number which would be exactly divisible by 78. So hence choice B here should be the correct answer. Now, which of the following numbers will always divide xy, xy, xy type of a 6-digit number, where x is greater than or equal to 1, less than equal to 9, and y is greater than equal to 1 and less than equal to 9. Now let us take a number which is of the type xy, xy, xy type and divide that number by the numbers given in the choices turn by turn. So the value of x cannot be less than 1. The value of y also cannot be less than 1. So let's take a number 1, 2, 1, 2, 1, 2. Now let us divide this by 1, 0, 1, 0. First thing, you have a 0 here in the units place. So obviously this number has 2 in the units place. It will not be divisible by 1, 0, 1, 0. So let us remove this. Now 1, 0, 1, 0, 1 sounds good. So 1, 0, 1, 0, 1 is what we will take here. Goes by 1, 1, 0, 1, 0, 1. Get a 0 here, a 2, a 0 here, a 2, and you take down this 2. So 1, 0, 1, 0, 1 into 2 is 2, 0, 2, 0, 2. Hence, choice B here is the correct answer. So simply you have to create an example, create a number which is of the type xy, xy, xy. We took it as 1, 2, 1, 2, 1, 2. And we try to divide this by the number given in choice A, which is ending in 0. So obviously this will not be divisible by a number ending in 0. Then we try to divide this by 1, 0, 1, 0, 1, which worked out. So hence this became our answer. Now one doubt that might cross your mind is that the number should always divide such kind of a number. So if you want, you can test this number with the other two choices which are remaining. In choice C and D, we have two numbers. So let us take up this number 11011. Go by, you multiply with 1, so 11011 becomes 0111. Take down 2. Now 11102 is definitely not divisible by 11011. So hence that is why choice C is incorrect. Let's take the case of choice D, 121212, and divide this by 11010. Why should we divide this by this number? Not required, because again this is ending in a 0. So obviously this number has digit 2 in the units place, whereas you're dividing by a number which ends in 0. So its multiples must end in 0 as well. So hence choice D also cannot be the answer. Cyclicity of numbers, another important subtopic of number system. We talk about the powers of numbers. Let us say from 2 to 9. Let us take the instance of 2. Now 2 power 1 is 2. It's a single digit number. Now 2 power 2 is 4. It's a single digit number. 2 power 3 is 8, another single digit number. And 2 power 4 is 16, which ends in 6. We are just bothered about single digits. We are just bothered about the units digit. Now 2 power 5 will again give us 32, and this is the units digit. So 3 should disappear here. 2 power 6 is 64. So again, ends in 4 units digit. 2 power 7 is 128, ends in 8. So we don't need the other two digits. And 2 power 8 is 256, ends in 6. Don't need 25 here. Now observe carefully. 2, 4, 8, 6. Again, 2, 4, 8, 6. This is a cycle which will keep on repeating after every 4 powers of 2. So that means that 2 has a cyclicity of 4. What do we mean by that? After every 4th power, we will get the same digit in the units place, whatever may be the power, as you can see. So that is why 2 has a cyclicity of 4. Now similarly, for 3, 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27. We don't need this 2. 3 power 4 is 81. We don't need this 8. 3 power 5 is 243. We don't need this 24. Again 3 has appeared. See, 3 power 1 is 3. Again 3 power 5 is 3 in the units place, which means the cyclicity of 3 also will be 4. After every 4th power, the same digit appears in the units place. So we can say that the cyclicity of 3 is 4. Now look at 4, number 4. 4 power 1 is 4, 4 power 2 is 16, we don't need this 1. 4 power 3 is 64, don't need this 6. 4 power 4 is 256, we don't need this 25. See, after every second power, the same digit is repeated. So we can say that number 4 has a cyclicity of 2. That is, after every 2 powers, the same digit appears in the units place. Talking about 5, 5 power 1 is 5, 5 power 2 is 25. Remove 2, 5 power 3 is 125. Remove 1 and 2. Take any power of n in the units place. Always digit 5 will be found. So that is why we can say that number 5 has cyclicity of 1. Every 1 power has digit 5 in the units place. Similar is the case with number 6. 6 power 1 is 6. 6 power 2 is 36. Remove this 3. We just need the digit in the units place. 6 power 3 is 216. Again. So you find that every 1 power, so we find that at a difference of every 1 power, the same digit 6 appears in the units place. So 6 power n will still have number 6 in the units place. So we can say that number 6 has cyclicity of 1, similar to the cyclicity of 5. Now 7 power 1 is 7. 7 power 2 is 49. Remove 4. 7 power 3 is 343. Remove 34. 7 power 4, 2401. So we get 1. Then 7 power 5, again we will get 7 in the units place because you're going to multiply 7 with 1. So once again we find that after every 4 parts, the digit in the units place is repeating for the powers of 7. So 7 has a cyclicity of 4. Now similarly, let's have a look at the cyclicity of 8. 8 power 1 is 8. 8 power 2 is 64. Don't need this 6. 8 power 3 is 512. We don't need this 51. 8 power 4 is 4096. We don't need 409. So 8 power 5, 8 6 are 48. You will multiply this 5th power with 6. Then in the units place again you will get 8 only. So that means after every 4th power, the units digit is repeating itself. So we can say that number 8 has a cyclicity of 4. Now let's talk about the remaining number, that is 9. 9 power 1 is 9. 9 power 2 is 81. Remove 8. 9 power 3 is 729. Remove 7 and 2. Once again, 9 is repeating itself. After every 2 powers, the digit in the units place is repeating itself. So we can say that 9 has a cyclicity of 2. Now here we can see that in the cyclicity of 2, whatever the powers that we are taking, the last digit or the units or the digit found in the units place could be 2486. It ends in 6. It's an even number. And for 3, the last digit for its powers can be 3971. It ends in 1. So the cyclicity here shall be of 4. For number 4, the cyclicity is of 2 and it ends in 6. For number 5, the cyclicity is only 1 and any power of 5 ends in 5. Similarly, any power of 6 ends in 6. Its cyclicity is 1. For 7, the numbers which are powers of 7 will end in 7, 9, 3 or 1. So 1. So the cyclicity of 7 ends in 1 and its cyclicity is 4. 8. The numbers obtained through the powers of 8 are 8, 4, 2 and 6. That is, it will have cyclicity of 4 and the cyclicity of 8 ends in 6. 9, the cyclicity is of 2, 9 to the power anything. So a number which is 9 to the power anything, 9 to the power n, when we expand that, the units place will consist of either 9 or 1. So the cyclicity here ends in 1. Now what do I mean by saying cyclicity ends in 1? Because after that, the next group will consist of same numbers. So if it is 9, 1, again 9, 1, then the next group will be of 9, 1 and so on. Now what we must notice here is that 2, 4, 6 and 8 are all even numbers. And the cyclicity of all the even numbers, it ends in 6. Whereas 3, 7 and 9 are odd numbers. If we leave out 5, the other 3 odd numbers are 3, 7 and 9 and their cyclicity is ending in 1. After that, a new group will start. And 5 is an exception which ends in 5. So this point you need to keep in your mind that for any even number out of 2, 4, 6, 8, you take its cyclicity. It will always end in 6 in the units place. And after that, the same group will keep on repeating. Whereas for the odd numbers except 5, that is 3, 7 and 9, the cyclicity will end at number 1 in the units place. After that, new group will start. So numbers that follow the cyclicity of 4, there are 4 such numbers, 2, 3, 7, 8. You can easily memorize them. See, 2 plus 8 is 10, 3 plus 7 is 10. So these are complements of 10. Numbers that follow the cyclicity of 2 are only 2, 4 and 9. And incidentally, these are squares as well, aren't they? So you can remember that the 2 numbers which are squares from 2 to 9, which are those 4 and 9. Their cyclicity is 2. And numbers that follow the cyclicity of 1, there are only 2 such numbers, which are those 5 and 6. Now, where and how to use this information or this concept of cyclicity? Now, in this question, find out the number in the units place of the following product. That is 4783 raised to 245 into 621 raised to 72. Quite a huge product. Obviously, you're not supposed to calculate it. Now, we want the number in the units place. So what we will do is, we will select the numbers in the units place. So here basically we want 3 raised to 245 and here we want the number in the units place for 1 raised to 72 and the product of these two. Now we know that 1 raised to any number, that is 1 raised to n, will always give us 1. So here we will definitely get 1. Now 3 raised to 245. Now you see the power here is 245 and we know that the cyclicity of 3 is of 4 powers and it ends in 1 in the units place. So what we will do is we can rewrite this 3 raised to 245 in such a way that first we will take a number which is less than 245, but it is the nearest multiple of 4. So we can write this as 3 raised to 244 plus 1 into 1. So into 1 doesn't make any sense. So let's clear that off. Now let's focus on this only. Why 244 plus 1? See, number 3 has a cyclicity of 4 powers. Now there are 245 powers. So if you divide it by 4, there will be 61 groups of 4 powers. And after every 4 powers, we will get the same digit in the units place because 3 has a cyclicity of 4. So that is why it was important that you write the nearest multiple of 4, the one which is nearest multiple of 4 but lesser than 245, and the remaining power, that is 1. So this becomes 3 raised to 244 into 3 raised to 1. Now 3 raised to 244 is the same as 3 raised to 4. And 3 raised to 1 is nothing but 3. 3 raised to 4 ends in 1 into 3 from here. So digit 3 should appear in the units place. Now I want you to understand this properly, that this number here has to be a multiple of 4 because the cyclicity of 3 will end in the 4th power. And the units digit in the 4th power is 1. So calculation bit will become much more simpler because you will have to multiply the remaining power here with 1 only, which is redundant. Here 3 is given to us in choice C, which becomes the answer. So to establish the concept in your mind, I'll take another example. Let us say you have a number 1, 4, 5 and 8 raised to 622. Now you have to find out the units digit in the expansion of this expression. So units digit we need, so we will only take 8. We will ignore 145. Hence, we get 8 power 622 as our interest. Now we know we have to deal with powers here. And 8 has a cyclicity of 4. Now whatever is the cyclicity, we will take the nearest multiple of 622 for that cyclicity. By that I mean this is going to be 8 raised to 620 plus 2. Why? Because 620 is divisible by 4 and it is the nearest multiple of 4. Now this we know further is 8 raised to 620 into 8 raised to 2. Now because 620 is divisible by 4, you can write it as 8 raised to 4 into 8 raised to 2. The whole point is 8 raised to 620, if you divide this by 4, it becomes 8 raised to 4 ones are 4, then 22, 8 fives are 20, 8 fives are 20 into 4. Why should you do this extra bit of work? 155 into 4 is 620. Not required. There are 155 groups of 4 powers. Anyhow, whatever digit is obtained in the units place for 8 raised to 155 into 4, or let us say 8 raised to 620, is going to be the same digit which will be found in the units place of 8 raised to 4, which we know ends in 6. 2, 4, 6, 8, even numbers. The cyclicity of the last power, the 4th power, here should end in 6. And if we take 8 square, that is 64. So we should get 4 here. So 6 into 4 is again 24. 2 we are not interested in. 4 is definitely what we need. So hence 1458 raised to 622, in the units place we will find the digit 4. The numbers obtained through 2 raised to 6n minus 4 raised to 2n, where n is a natural number, will always be divisible by 15, by 18, by 36 or by 48. Take an instance. For n is equal to 1, 2 raised to 6n minus 4 raised to 2n should be equal to 2 raised to 6 minus 4 raised to 2. The value of n is 1. Now we know that 2 raised to 6 is 64, from which we subtract 16. So what we get here is a 48. Now this n is equal to 1 itself is giving us the answer here, and that is 48. Now this number 48 is not divisible by 15, not divisible by 18, not divisible by 36. It's only divisible by 48. So hence choice D should work out to be the correct answer. You don't have to be scared. You don't have to get intimidated because this particular equation is given. So just relax and put a value for n. We took it as 1 and we came up with our solution. Now find out the remainder obtained on dividing 3 raised to 21 by 5. So 3 raised to 21 by 5. We know 3 raised to 21 has to be written in such a way that first the power has to be divided by 4, or let us say we have to write the nearest multiple of 4. And the nearest multiple of 4 and the nearest multiple to the number, and for 21 the nearest multiple of 4 is 20. So we will divide this by 5. So now we know that this is 3 raised to 20 into 3 raised to 1 by 5. Now 3 raised to 20 ends in 1. We are just bothered about the units digit. Into 3 raised to 1, that is 3. So 3 when divided by 3, remainder obtained obviously will be 3 only. Now this is given to us in choice C, which becomes the answer. So alright guys, so in this session we discussed the important basic fundamentals of number system, and we saw variety of questions which were based on the questions that appeared in the previous year CSAT papers. We will meet again in the next session to discuss another topic. Till then, my best wishes are there with you. Please do work hard and stay safe. Thank you.